Our next speaker is Justin James with the iRODS Consortium, and his talk is entitled iRODS S3 API 0.2.0 with Multipart.
Okay, thank you. Yeah, so I'm going to talk about the S3 API. Specifically, I'm going to go into some detail about how we implemented Multipart, which was a recent enhancement to this. Okay, our goals. Basically, we've had a longstanding goal of making iRODS available to non-iRODS aware clients and APIs. So this is just another approach to that. We want to be able to present iRODS as the S3 protocol so that any S3 client or S3 API can communicate with iRODS without knowing anything about iRODS. Some sub goals of that is that we want to be able to support multiple users and multiple buckets. Also, we want it make sure it's load balancer friendly and the code is maintainable. Okay, some history on this project. Some of you may remember that this was also talked about in last year's UGM. So the working group was first started in 2021, and in 2023, one of our interns, Violet White, did the first implementation and implemented some of the initial endpoints for this API. Finally, in November of last year, we got it all. We had the inputs all working, and we had 0.1.0 released. And then in March of this year, we released 0.2.0, which added Multipart support. Okay, the architecture, this is kind of the same as if you saw it last year. It's what we had. So basically, it's pretty simple. The S3 API just sits between the S3 client and iRODS. So it's a server to the S3 client and a client to iRODS. It's single binary and single configuration file so that it's easy to install and configure. And we'll see a little bit more of the configuration later. Again, multi-user, multi-bucket support. And one thing you would need, though, is it requires RODS admin credentials so that we can proxy to whatever user we need to. The status of it, we have all the testing passing with both the AWS and MinIO CLI clients, and also the Boto3 and MinIO Python library clients. Okay, so since this was introduced last year, I wanted to go through a few of the changes that have happened in the last year. First, originally we just had some Python files that kind of did some testing. It wasn't really a proper testing framework. So we did add a Docker based framework using Python unit tests. Signatures were not working with every client. So we debug and fix that. So now it's working for all the clients. Again, we implemented multi-part upload, which I'll talk about later. We did have to, if you remember Marcus's talk yesterday, our new toolchain, compiler toolchain does not support coroutines, so we had to move away from the coroutine implementation, and so we moved it to the same implementation that the HTTP API that Corey talked about uses. So we have foreground, background task. We use Boost Beast HTTP and as a library to support the HTTP part of it. And in the process of doing this transition, we changed that from synchronous to asynchronous calls. Marcus made changes to CMake files and that he talked about yesterday. And we noticed we weren't supporting range headers for get objects, so we added that support. List objects, the API isn't real clear on how list objects is supposed to work. And so we started testing it, comparing it, how it works with the Amazon server versus how our API talking to iRODS works. And so we kind of re-engineered that so that our list objects v2 works hopefully exactly like the Amazon. We believe we do have it working like that. Chunk encoding. The Boost Beast HTTP does support chunk parsing of chunks, HTTP chunks. Unfortunately, there's kind of an inconsistency between the S3 protocol and HTTP. HTTP says that if you're going to have chunk encoding, you have to have a certain header set, and Boost Beast HTTP will not parse chunk encoding unless that header is set. S3 does not require that header to be set, and the clients that we tested that use chunk encoding do not set that header as well. So we had to actually manually parse the chunks for that. And finally, we implemented a few new endpoints. Okay, so on the left side, you see the endpoints we've implemented. I think we got pretty good coverage on the most useful endpoints for S3. A couple of these we had to stub just because the clients called these in. They're not really important to us, but the clients called them in the background, so we had to actually return just a stub for them. And we're investigating some additional endpoints. One is the legacy list objects endpoint for S3. We don't have that implemented yet, but we probably will in the near future. ACL and tagging support. Upload part copy. We realized that we do support upload part, but there's a certain header that makes it an upload part copy. We have not supported that yet, so we'll add that support. And finally, abort multi-part upload. Very simple to implement, but we just haven't done it. Okay, the configuration looks a lot like the HTTP configuration. It's basically two stanzas. One is how we appear at, is kind of defines the thing between the S3 client, the configuration that's needed between the S3 client and the S3 API. And the other one is just how the API connects to iRODS. Okay, so here's the S3 server stanza. Most of it's self-explanatory. I won't go into all of it, but a couple things to point out. There are plugins for the bucket resolving. So basically right now we map a bucket to a collection in iRODS. So depending on what bucket the client writes it to, that will map directly to a collection in iRODS. The authentication resolver that maps a S3 key secret key pair to an iRODS user. Now this is a plugin architecture. When we made the transition to remove coroutines and use a framework that the HTTP API used, we took out, just for simplicity and get it done, we removed the plugin architecture from this. So these are currently not plugins, but they will be. We'll add them back in as plugins in the near future, and that way we can add different functionality with different plugins for the bucket resolving and the authentication. Okay, the iRODS client section is all self-explanatory. The only thing I'd like to point out is we do define the resource. So when you add new files through the S3 API, we'll define that will go to that resource. Okay, Multipart. This was the most complex part of it. And I want to go, before I go through these options that we investigated, I'll tell you a little bit about why Multipart is difficult. Basically, iRODS talks POSIX, essentially. So when you write a new file, open, seek, write, close. The problem with implementing Multipart is we don't know where to seek to, because Multipart, each part you're given a part size and a part number. Each part they can all be at different sizes. So if I'm part 10, I don't know where I'm seeking to. That makes it more difficult. Anyway, so it doesn't make it difficult to implement. It makes it difficult to implement efficiently. So we went through several options. One was multi-object, where each part was an object in iRODS. The second option was the simplest option, which was a store and forward. So we would store each part on the S3 API server, and then once complete multi-part upload executes, we would create the file in iRODS, have a bunch of threads write to iRODS. And finally, there was a store and register approach. I'm sorry. The efficient store and forward is the idea is to kind of basically do store and forward a little bit more efficiently. And I'll talk more about that as well. And store and register. Okay, so our first implementation, what we have right now is just the easiest implementation, which is the store and forward. So it's pretty simple. Create multipart. All it has to do is generate a unique ID for the upload ID and return it to the client. And then upload part, the S3 API will just write to the local disk for each part. And then finally, complete multi-part upload is where a lot of the magic happens. So that's the point where we actually create the object in iRODS. At this point, all the parts have been written, so we know the offsets. So we can create a bunch of threads that go and seek in iRODS and write. And then finally, once they've all written, it will return back to iRODS. A drawback, well, there's a couple of drawbacks to this approach. One is it's not very efficient because we're doing 2 read-write cycles. Finally, most clients kind of expect complete multipart to return almost immediately, and we're not doing that because we're doing that second read-write cycle in complete multipart. And finally, abort multipart upload, which hasn't been implemented. All we'd have to do is remove the temporary part files from the API server. Okay, performance. So this is the performance for large files. So the upload time would be with multipart, and download time is just multi-threads seeking and reading. The y-axis is the time, and the x-axis is the test for various file sizes from 200 megabytes to 1800 megabytes. What I hoped was that the one on the left would be close to, this is comparing writing to a local ManIO server, comparing that with writing to iRODS via the S3 API. I hoped that the one on the left would be closer together. We are significantly slower than on reads than just reading from a ManIO server. I'm hoping we troubleshoot that and improve on that. The one on the right was totally expected because of the way we've implemented multipart. It's at least, I mean, we knew it was going to be at least twice as slow because of the 2 read-write cycles. Okay, so we do want to enhance the multipart upload. One is the efficient store and forward approach. This is, we're just looking at brainstorming this out at the moment. So here's some, I just wrote down some ideas of our current brainstorming. The idea is that we're going to write, if we know the part. So if parts come in order, and we know the part as soon as upload part is called, we'll know the offset. If we know the offset for a part in, rather than writing that to the S3 API, we will just write it to iRODS. We'll create the file if needed, seek, and write it. If we don't know the offset, then we have to write it locally. But we may be able to start streaming earlier before complete multi-part upload is called. There is a open question on this approach, and that is parts can be resent, and the part size may change on resending it. So if they say they send part 1 and it's 5 megabytes, and then they resend it 10 megabytes, well, that messes up all of our offsets. So we'd have to consider what we're going to do about that. We may just say that we're not going to support that. Like, we'll just send an error saying you can't do weird things like that. Another approach to multipart, which would be the second approach that we would implement, is the store and register. And the idea there is that we would just, instead of writing to the S3 API, the S3 API server is either co-located with an iRODS server or it has access to a mount for the iRODS server. So we would write the parts on that server, and then we would call copy file range, which is a kernel level call, which should be faster than doing read and writes yourself. Sorry. So anyway, we call copy file range, and then at that point, it would accumulate all those part files into one. Now, this approach has some challenges. One, we're not executing policy, which is good because we don't want to execute a bunch of iRODS policy just for parts, which you wouldn't expect. The problem with that is you have to execute policy to figure out where a file is going, because we've defined the resource, but that resource could be the head of a composable tree and things like that. So we're not executing policy to say, oh, well, this file is supposed to go to this actual resource. So we would have to say, you're just going to write it, you're going to define where it goes, and you're going to register it at that server. So we would be skipping the whole resource composition policy step. Secondly, what if the S3 API is writing to an object store? Obviously, we can't call copy file range if we're writing to an object store, because that doesn't make any sense. But we do think this approach would be faster. But the complete multipart upload would still have to wait until that copy file range completed. So what we're thinking about doing is offering both the efficient store and forward and the store and register as options that you can use, with some strong caveats on how store and register would work. Okay. Next steps, we want to expand our testing framework. We want to implement the efficient updates for store and forward, which would be the first improvement on Multipart. Add additional endpoints for tagging and ACLs, and add additional plugins for bucket mapping and user mappings. Okay, so 0.2.0 has been released on March 6th, and it's available on Docker Hub. And that's it.
Any questions for Justin? All right, we got one here.
Give me 1 second so I can actually hear the questions. Okay, that's not going to work. All right. I was worried about that.
Without it. Okay. So the problem is then that you have to write the POSIX. So if the S3 API would have knowledge of iRODS itself, and you would have an S3 resource, then you might just stream the multiparts to the S3 multipart in the backend, then, or is that? Because then you don't need to know the offset, because your resource is S3 as well.
If we're right, that's possible.
Mike.
It is possible that if we were writing to an S3, so we're pretending to be S3 in the API, and we're also writing to S3. Yeah, maybe we could have special code that would be like, okay, we'll just pass it on through to S3. Yeah, that would be possible.
Any other questions? All right. Well, if you do have questions, please ask in the Slack channel. Thanks, Justin.